Hi, so this video is about binomial distribution and the normal approximation to the binomial. Okay, so normally this is how it's asked. They'll ask you first a nice normal binomial question. So in this case, a factory makes water pistols, 8% of which do not work properly. A random sample of 19 water pistols is taken. Find the probability that at most 2 do not work properly. Okay, so you've obviously got to get your head around, you should recognize that it's binomial, but then get your head around the fact that it's at most 2. So try and think about what does at most mean to you. I always think of if your parents told you you are allowed at most 2 beers when you go out, that means you are allowed not 1 or 2 beers. So think like that and you'll figure out quite quickly what at most means. So that would be naught. So the binomial would be 19 combination naught, 8 to the 0.08 to the naught, and so on. Or it would be 1, 19 choose 1, or it would be 19 choose 2. Okay. Right, so that's sort of a nice question. Again, I wouldn't spend too much time on the calculator trying to figure that out. I'd wait until the end. Okay, so this question has come up a few times and it seems to catch people. In a random sample of n water pistols, the probability that at least 1 does not work properly is greater than 0.9. Find the smallest possible value of n. So the trick with this is that it works with at least 1, because at least 1 is 1 minus the probability of none. So you can say 1 minus probability of no n's, and you can sub values in. Now what that means is that NC0 falls away because that's a 1, and 0.08 to the power of 0 is also a 1. So you end up with a nice little equation where you can use logs to be able to solve it. Okay. So this is sort of the binomial, and then you can expect the question straight after that to be based on that. All right, so in this question here, it says a random sample of 1,800 water pistols is taken. Use a suitable approximation to find the probability that there are at least 152 that do not work together. Okay, so you can expect this question. It's the second year that it's going to be asked. You're guaranteed to get asked it, all right? So we're looking for the idea of a suitable approximation, which means that we want to approximate to the normal, all right? So, well, to the binomial, but from the normal. So our expected value of x, which you guys are expected to know, is what your mean is. So that's your mean, which is your expected value of x is 144. Your variance is n times p times q. All right, so the standard deviation is going to be the square root of that. Okay. Your next step that you want to make is you want to do a continuity correction. Okay. So this is where it sort of is quite tricky, and you might want to sort of ask questions about this one. And that is, they've asked us the probability there are at least 152 that do not work properly. So at least 152 is the probability that x is basically including 152. So at least 152 means that 152 needs to be included in your rectangle. So the probability that what we are doing, the correction, would be the probability of x is greater than or equal to 151.5. Okay. If it had said the probability that it was greater than 152, then my continuity correction would be 152.5. Okay, so once we've decided on the continuity correction, we are then going to solve it. So we're going to solve it like a normal distribution curve. So we're going to put our mean at 144. And we're going to look at what we're asking for. So when x is greater than 151.5. Okay, so I'm looking for this section over here. So I'm going to again get a z-score, which is 0.6516. And I'm going to look that up in my table, and I'm going to get 0.243, right? So what is this? This is now the probability of, basically I want the probability that x is greater than 151.5. So I'm actually looking for this side. So again, I'm going to go 0.5 minus that probability, and I'm going to get 0.257. And that is the probability of what they're asking us, that you would get at least 152 that do not work properly. Now, if the next question, which I think is quite valid, is if they ask us if this approximation is valid. So remember that the approximation is only valid. You can always perform the approximation. You can do NP and NPQ and get your variance, and you can do it easily. But what makes it valid is if the n times by p and your n times by q are both greater than 1. I mean, greater than 5. And if they are both greater than 5, then the normal approximation is valid, which means that you can accept the solution that you've got, that would be the probability. Okay.